Hey, hello everyone. Welcome to our workshop today. Today we're going to talk about reducing emissions from operational practices of commercial aircraft. This is the first of a series of workshops on this topic. Now I will turn it over to Dr. Michael Benjamin, the Division Chief of Air Quality Planning and Science Division of CARB, to give an opening remark. Over to you, Dr. Benjamin.
Thank you, Mo. Good afternoon, everyone. My name is Dr. Michael Benjamin, and I'm Chief of the Air Quality Planning and Science Division here at the California Air Resources Board, or CARB. In my role, I oversee air quality planning, emissions inventory, and modeling efforts at the agency. In addition, I oversee our airport and aviation emission reduction programs. I'm pleased to welcome you to our first workshop on the topic of reducing emissions from in-use operations of commercial aircraft in California. As you'll see momentarily in our presentation, there are several air quality programs and initiatives to reduce emissions from equipment operating at airports. However, we project emissions will continue increasing without further action. This past summer, on July 22nd, 2024, CARB, the U.S. Environmental Protection Agency, and the South Coast Air Quality Management District each signed a letter of intent on actions that will be taken to address emissions from aircraft and other sources that have been mostly regulated at the federal level. Among other actions, CARB committed to pursue a regulation to reduce emissions from ground operations of aircraft. However, this is not a new action. It dovetails with previous CARB commitments for the aviation sector in the 2022 State Strategy for the State Implementation Plan for the most recent ozone standard. Over the past couple of years, my team has been exploring opportunities to reduce emissions from aviation. Today, they're going to present some background, initial concepts to achieve emissions reductions, and questions they have for you. The material we are presenting today is preliminary. We will be presenting concepts that will undergo further refinement, adjustment, and iteration in the months ahead. I repeat, the ideas being presented and discussed today are just concepts. They are not a formal regulatory proposal. We thank you for your participation in today's workshop and are looking forward to further dialogue with you as we continue this process. Let me now direct your attention back to Dr. Mo Chen, who will begin the workshop presentation.
Thank you, Dr. Benjamin. Before we get started, I'd like to cover a few important logistic details regarding today's workshop. First, for those who prefer to join via telephone, you can call in using the number 888-363-4734. Please use the access code 350021 when prompted. Please note that this workshop is being recorded. After the workshop, both the slides and the recording will be made available on CARB's Zero Emission Aircraft Ground Operations webpage. This will provide an opportunity for you to review the material at your convenience and share it with those who may not be able to attend today. Next slide, please. We will pause for questions halfway and at the end of the workshop. Please raise your hand if you would like to ask a question verbally, or alternatively, you can type your question in the Q&A box. In your question, please include a reference to slide number if applicable. If you're using Zoom application, you can use the raise hand feature. If you are calling in on your phone, you can press #2 to raise hand, and then press *6 to unmute yourself when you get a verbal cue to do so. You will also have a chance to submit additional questions after the workshop to aircraft@arb.ca.gov or my work email mo.chen@arb.ca.gov. Next slide, please. The slide lays out today's agenda. We will start with some background explaining the necessity of addressing emissions from aircraft. Then we will introduce some regulatory approach concepts and solicit feedback. After that, we will have our first Q&A session. The second half of the presentation includes emission inventory updates and timeline for next steps. At the end, we will have a second Q&A session. I will now pass it to my colleague, Dr. Jack Johnson, to start the background portion of the presentation.
Thanks, Mo. So to get started, over the last few decades, emissions from mobile sources have decreased substantially due to both state and federal regulatory work. Mobile source emissions from California regulated sources, which includes cars, trucks, and other off-road equipment, has dropped by 73% as of 2020, and will have decreased by over 90% by 2037. In recent years, emissions from federally regulated sources like interstate trucks, planes, trains, and ships have surpassed the California regulated sources and are projected to be more than double California regulated sources by 2031. These emissions trends indicate that there is still more work to be done in reducing emissions from these primarily federally regulated sources. To get into more details about which mobile source emissions will become more significant in the future, here we are plotting the 2024 NOx emissions from each mobile source category compared to their NOx emissions in 2050. The y-axis here is showing the NOx emissions in tons per day of each source category. As you can see from this plot, all categories of mobile source emissions are expected to decrease between 2024 and 2050, except for aircraft. Aircraft NOx emissions are expected to increase by 30% between now and 2050. This trend is clearly highlighting the lack of emissions control measures for aircraft. The projected increase in emissions from aircraft is concerning, especially considering the NOx emission reductions needed to meet the targets outlined in the 2022 state SIP strategy. In the SIP, it is estimated that an 80% reduction in aviation emissions is needed in order to meet the 2015 ozone standards. This reduction in the South Coast Air Basin could solely be achieved by reducing commercial aircraft emissions, which in the South Coast makes up approximately 90% of all aircraft NOx emissions. This trend, both statewide and for the South Coast specifically, shows how there is a huge potential to reduce NOx emissions from commercial aircraft alone. CARB's 2022 scoping plan has also set aggressive emissions targets to achieve carbon neutrality for aircraft. Through the scoping plan, 20% of aviation fuel demand will need to be met either through electricity or hydrogen by 2045, with the remaining 80% met by sustainable aviation fuel or SAF. These targets for the aviation sector will be crucial in reaching California's goal of carbon neutrality by 2045. There are many reasons why emissions reductions are important, with the most prominent being the health impacts of jet fuel to passengers, pilots, airport and ground support workers, as well as communities that live close to airports. Poor air quality has been linked to many health conditions, including decreased lung function, asthma, other respiratory illnesses, and premature death. These health impacts are caused both by burned and unburned jet fuel, And a study done in 2021 by the National Research Center for the Working Environment in Denmark showed that jet engine emissions have similar physical and chemical properties, as well as health effects to diesel particulate matter. Jet fuel emissions have been shown to affect the health of airport workers and nearby communities. A white paper released by SEIU in 2024 showed that airport workers can be exposed to particulate matter concentrations 6 to 9 times higher than concentration measured on busy streets. Because of these negative health outcomes, airport worker unions have been strong advocates for emissions reductions in the aircraft sector. In addition to high exposure levels in airport workers, a monitoring study conducted by USC in 2014 showed that particle number concentrations are 4 times higher, even 10 kilometers downwind of Los Angeles International Airport. Communities that are closer to the airport had measured particle concentrations as high as 8 times above background levels. Leaded aviation gasoline, or avgas, has also been a concern in recent years due to the potential for exposure to lead emissions. A recent endangerment finding from the EPA found that there were increased concentrations of lead in children's blood that lived near airports, particularly those airports with higher general aviation activity. While leaded avgas is typically not used in commercial operations, it is still an air pollutant of concern from aviation. In response to some of these findings, Senate Bill SB 1193 was passed in California to ban the sale and distribution of leaded avgas in California by 2031. Currently, there are 14 airports in California that offer the 94 octane unleaded avgas. However, only about 30% of general aviation activity can use the lower 94 octane fuel in their engines. There are now 2 airports in California offering 100 octane unleaded avgas, and this will cover the remaining 70% of general aviation activity in California. I will now pass it to my colleague, Dr. Cindy Yanez, to discuss aircraft engine standards.
Thank you, Jack. Next slide. So emissions from aircraft engines are regulated at the international and the federal level. The International Civil Aviation Organization, or ICAO, sets emission standards for 193 member states, which each adopt these standards in their countries domestically. New environmental policies and standards are advised by a committee within ICAO called the Committee on Aviation Environmental Protection, or CAPE. The timeline on this slide shows the emission standards set by ICAO over the last few decades. The first standards were adopted in 1981 and included engine emission standards for NOx, CO, hydrocarbons, and smoke. Since then, the NOx standard was tightened 4 times in 1992, 1998, 2004, and 2011 by 12 to 20% relative to the previous standard. In 2017, CAPE adopted the first emission standard for greenhouse gases, and in 2019, they established a new emission standards for non-volatile PM. While ICAO sets an international standard, US EPA is responsible for setting the aircraft emission standards domestically. US EPA has authority to set stricter standards than ICAO domestically, but traditionally they harmonize with the federal standards with ICAO. These emission standards are set under a technology following approach rather than a technology forcing approach. This means that the standards can be met with technology that's already in use. Therefore, these standards do not impose any pressure onto aircraft engine manufacturers to develop lower emission technologies. We estimate that without an 80% reduction in the CAPE 8 NOx standard, California cannot meet federal air quality standards. Next slide. The federal government has initiated some programs to help advance new aircraft technologies, FAA organized a cost-sharing program called the Continuous Lower Energy Emissions and Noise Program, or CLEAN, which aims to accelerate the maturation of new aircraft technologies. The program provides one-to-one cost matching with aviation industry companies who develop a technology that reduces noise, fuel burn, or emissions below the CAPE standards. The goal of this program is to incentivize the development of new aircraft or engine technologies and alternative jet fuels that aviation manufacturers may not have taken on otherwise. In the current phase of the program, CLEAN 3, the goals are to reduce noise, fuel burn by 20% relative to the CAPE 10 standard, NOx emissions by 70% relative to the latest standard, and non-volatile PM emissions lower than the CAPE 11 standard. The CLEAN 3 projects are ongoing right now until 2026, and the program targets to get these technologies to enter service by the year 2031. Several of the technologies from previous phases, CLEAN 1 and CLEAN 2, are already commercially available and are in service today. Next slide. A good example of a successful technology that came out of the CLEAN program is the twin annular premixing swirler, known as TAPS, which is a lean burn combustor that was developed by General Electric through CLEAN. Lean burn technology limits the conditions under which NOx is formed by lowering the combustion temperatures, since NOx primarily forms under high temperatures, and by promoting a more thorough mixture of air and fuel before combustion through a swirling mechanism. The diagram on the left shows how the TAPS technology has evolved over time. The first TAPS was developed before CLEAN and was installed in GEnx engines in some Boeing wide-body aircraft. Then the TAPS 2 combustors were installed in LEAP engines that are designed for narrow-body aircraft, including the Airbus A320 series and the Boeing 737 MAX series. The most recent TAPS 3 combustor will be in the GE9X engine that's designed for the Boeing 777X wide-body aircraft, which has not yet entered service. And the figure on the right of the slide shows where some of these low NOx technologies fall relative to the NOx emission standards. The NOx standards for aircraft engines are a bit complex because they vary with the engine's overall pressure ratio and rated thrust. On this plot, the x-axis is the engine overall pressure ratio and the y-axis is the NOx certification value, which is calculated in units of grams of NOx per kilonewtons of rated thrust. The black lines on the plot show ICAO's NOx standards, which as you can see vary with the pressure ratio. Generally, higher NOx emissions are allowed for engines with higher pressure ratio. The triangles show NOx values of certified engines. The gray crosses are older engines that were certified before 2009, and the colorful triangles represent the engines with some of the most advanced clean technology. If you click next, Jack, I highlighted some of the engines that have a TAPS combustor in yellow, and the latest NOx standard is highlighted in blue. The LEAP 1A engine reduces NOx by 52% relative to CAPE 8, and the LEAP 1B engine reduces NOx by about 20 to 30% relative to CAPE 8. These technologies demonstrate that it is technologically feasible to achieve emission levels well below the CAPE standards. However, the emission standards lag behind and are not strict enough to push the envelope. Another factor to consider here is that the NOx emissions tend to increase when the engine's overall pressure ratio is increased. This is concerning because higher pressure ratios tend to improve fuel efficiency, causing a trade-off between fuel efficiency and NOx emissions. Some of the engines with cleaner combustors don't necessarily reduce NOx in practice because they're operating at higher pressure ratios. As can be seen on the plot, some of these new technologies reduce NOx well below the CAPE 8 standard, while others not as much, like the LEAP 1B, due to their higher pressure ratios. Some of the older engines in the gray points have just as low NOx as the LEAP engines because they operate at lower pressure ratios. Thus, the manufacturers make a decision or a trade-off to balance NOx emission reductions with improved fuel efficiency. Next slide. So overall, despite these technology development programs and the emission standards, certified aircraft engines have shown little NOx reduction over time. This figure shows the level of NOx certified for engines reported to the ICAO emissions data bank. In the plot, you can see that there has been little progress in achieving engines that are cleaner over time. For instance, engines certified in the 1970s have comparable NOx levels to the most recently certified engines in the 2020s. This slow advancement toward lower NOx engines is also related to the fact that I just mentioned about the trade-off between NOx emissions with fuel efficiency and also with noise mitigation. And simultaneous efforts for all three of those have resulted in a nearly flat trend for NOx. Although the NOx standard was tightened 4 times since the 1980s, this likely just prevented an increase in NOx emissions from fuel and noise reduction efforts over that time, but it did not reduce NOx. Next slide. Much of the aviation industry's current environmental efforts right now are focused on achieving net zero carbon targets by 2050. Plans to reach net zero rely heavily on the deployment of sustainable aviation fuel, or SAF, which significantly reduces CO2 emissions on a life cycle basis. In California, SAF use has been increasing since it was added as a credit-generating fuel in the Low Carbon Fuel Standard program in 2019. The plot on the right shows the amount of SAF that was loaded onto aircraft in California annually since 2019. SAF consumed in the state has increased from 2 million gallons in 2019 to 23 million gallons in 2023. These increases are significant, but these values are still less than 1% of jet fuel consumption in the state, and strong efforts and challenges still need to be overcome in order to upscale SAF use. Just recently, CARB signed an MOU agreement with Airlines for America to further increase SAF use in the state. This MOU sets a target of working with the aviation industry to have 200 million gallons of SAF available in California by the year 2035. While this target is a 10-fold increase over last year's volume, this amount is still less than 5% of the state's total jet fuel consumption. It is about 40% of jet fuel consumption for flights within California, but when accounting for interstate and international flights, this is still less than 5%. Far more SAF is going to be needed for the aviation industry to meet the net zero carbon goals. Also, while SAF has significant benefits in reducing greenhouse gas and PM emissions, it does not reduce emissions of NOx or toxics, which are of high concern for air quality. Therefore, not only is more SAF needed, but more actions beyond just increasing SAF are needed. Next slide. This slide shows that major partnerships from both the private and public sector are needed to successfully reduce aircraft emissions. Each entity that's listed here has a role to play and could leverage their primary responsibilities so that we work toward a more sustainable aviation sector. Starting with the government agencies, each have authority at different levels over aviation emissions. Next. Air districts can establish local incentive and voluntary programs such as the MOU between South Coast and their 5 largest commercial airports. Air districts also have authority to create an indirect source rule for airports. On CARB's side, we can leverage our authority to establish statewide rules for operational practices, create incentive programs, and set emission reduction targets. At the federal level, US EPA and the FAA are responsible for advocating and or setting tighter emission standards for aircraft engines, funding technology advancement through programs like CLEAN, and regulating safety, routes, and service. At the international level, ICAO's role is to set tighter international engine emission standards. And then moving forward to the airports can also take some action through their air quality improvement plans, infrastructure planning, and incorporating environmental initiatives into their lease agreements with their tenants, and by implementing local policies, for example, landing fees or curfews. And then next, the airlines could prioritize air quality in their operations and engage in opportunities to advance technologies and or operational practices. And then original engine manufacturers, abbreviated OEMs, they could work on investing into research and development of lower emission aircraft engines and GSE. There could also be intentional coordination between engine and aircraft manufacturers to maximize emission reductions and expand zero emission aviation. And last but not least, community members also play a very important role in this process. This includes any member of the public, but especially communities living near airports and airport workers. Community members have the local knowledge that all of the other agencies on the slide need to hear about so that we're informed about local perspectives and impacts of the aviation sector, and so that we can act accordingly. Community organizations are also key players in advocacy, community organizing, and increasing public engagement and awareness of the issues. Next slide. In the most recent state SIP strategy, CARB outlined the need for stronger emission reductions from aviation in order to meet air quality goals. We committed to explore feasibility and authority to promote 4 actions either within California or by advocating for federal action. Specifically, we described 1, the need for federal actions to adopt stricter emission standards for aircraft engines. 2, a measure to attract cleaner engines for aircraft traveling through California and for those aircraft to use cleaner fuels. 3, initiatives to transition to zero emissions ground operations at airports. And 4, an airport emissions cap. We plan to go to the board no later than 2027 with an update on these efforts and what opportunities are feasible to reduce aircraft emissions in the state. Next slide. As part of our efforts, we're conducting careful, in-depth analysis of our legal authority to promulgate rulemaking on emissions associated with aviation. Here on the slide, we listed a few of CARB's responsibilities under the Health and Safety Code. The first one, CARB is directed to control criteria air pollutants from mobile sources to attain air quality standards. We're also responsible for reducing greenhouse gases to specific levels to combat climate change. The Health and Safety Code also permits CARB to assess fees to cover costs of compliance of off-road mobile sources. We will be cognizant of potential federal preemption issues throughout the rulemaking, and our legal team is carefully reviewing any possible limitations. Now I will pass it over to my colleague, Dr. Ramin Tohidi, so he will discuss more on existing state actions.
Thank you, Sydney. Okay, California has set key regulations to reduce emissions at airports. The large spark ignition engine LSI rule starting in 2009 required large fleets to meet emissions limits for cleaner air. The in-use off-road diesel or D rule requires fleets to reduce their emissions by retiring, replacing, repowering, or retrofitting older diesel engines from 2024. Phases out older diesel engines and mandates renewable diesel. The zero-emission forklift regulation, starting in 2026, requires only zero-emission forklifts, phasing out older ones by 2028. The airport shuttle bus rule transitions shuttles to 100% zero emission by 2035. For vehicles, the Advanced Clean Cars 2 rule ensures all new passenger cars are zero emissions by 2035. The Advanced Clean Trucks rule increases zero-emission truck sales, while the Advanced Clean Fleet rule phases in 100% zero-emission government and drayage fleets by 2035. Then we have the recent partnership with Airlines for America aims to make 200 million gallons of sustainable aviation fuel, SAF, available in California by 2035. Lastly, based on a scoping plan, by 2045, 20% of aviation must be zero emission, with sustainable aviation fuels supporting the rest. Next slide, please. This slide highlights the key sources of mobile emissions at airports. First, we have on-road traffic to and from the airport, including passenger cars, taxis, and shuttles. Inside the airport, ground support equipment like baggage tractors and fuel trucks contribute emissions near the terminal. Next are aircraft at gates, which emit while parked and using auxiliary power units APUs. As aircraft move, emissions occur during taxiing on taxiways, and finally from landing and takeoff on runways. Each stage plays a role in overall airport emissions, and CARB is actively working to address emissions at every level. Next slide, please. This slide focuses on NOx emissions at the airports and where they come from. First, on-road traffic like cars, shuttles, and taxis emit NOx through the combustion of gasoline, diesel, propane, and natural gas. Next, ground support equipment such as baggage tractors and fuel trucks adds NOx to add to NOx emission, specifically from older diesel power machines. Aircraft at gates also contribute through auxiliary power units, APUs, and idling jet engines, which emit NOx even when stationary. Finally, aircraft taxiing, landing, and takeoff are major NOx sources, with takeoff being particularly intense due to high fuel consumptions. These stages highlight key areas where reducing NOx can be a big impact on air quality around airports. Next slide, please. This slide shows the contribution of mobile sources to NOx emissions at LAX in 2023. As you can see, aircraft are the dominant source, contributing 87% of the total NOx emissions. Breaking it down further, 81% of aircraft emissions occur during landing and takeoffs, staying within the nominal 3,000-foot mixing height, with 15% coming from taxiing and 4% from auxiliary power units. The remaining sources are on-road traffic, contributing 10%, and ground support equipment, which adds 3%. Next slide, please. How are these NOx emissions being addressed and regulated? For the 78% contributed by aircraft, there are no CARB regulations or technology forcing standards in place to directly control these emissions. The 10% from on-road traffic is targeted through regulations such as ACC2, ACT, ACF, and zero-emission shuttle bus rules, which aims to transition vehicles to zero-emission alternatives. And finally, the 3% from ground support equipment is partially regulated under the ORD and LSI rules. Next slide. Okay, the purpose of today's workshop is threefold. First, we'll introduce draft regulatory approach concepts, providing an overview of potential strategies for reducing emissions. Next, we'll outline planned updates to the emissions inventory, focusing specifically on aircraft and ground support equipment. And finally, we aim to collect your initial feedback on these concepts and explore possible alternatives. As we present these concepts, we want to emphasize that these are just ideas and concepts at this stage. We don't have specifics yet. We are sharing these now to gather your thoughts and feedback. These are just concepts and ideas. We are here to explore possibilities and hear your reaction. We know there may be big questions about how these concepts would apply, and that's exactly the kind of input we are looking for today. Next slide, please. Okay, now I'll turn it over to Dr. Johnson to walk us through the details of our concepts.
Yeah, thanks, Rami. So for the next section of our presentation, we will be introducing our 4 concepts as part of this process. We would like to emphasize that these are just concepts and ideas that we have developed to reduce emissions from aircraft operations. The first of which will be a ground support equipment. Next, we will discuss aircraft operations at the gate. Following that, we will discuss aircraft taxiing. And finally, our last concept involves emissions reductions from takeoffs and landings. We'll likely continue to change and adapt these concepts throughout these future workshops and encourage all feedback that you may have. To start off, I wanted to give a quick high-level definition of airport ground support equipment, or GSE. Airport GSE includes all motorized equipment used on airside surfaces such as tarmacs, aprons, and taxiways, and they're used to support aircraft, passenger, and cargo operations, as well as other general airport ground functions. This equipment can be aggregated into 3 high-level categories shown on the right, including tugs and tractors, specialized trucks, as well as loaders and other on-site equipment. For the GSE portion of our concepts, our draft concept would be to transition all GSE fleets in the state of California to 100% zero-emission GSE. This could include technologies such as electric GSE or fuel cell electric GSE. Many of the categories of GSE already have zero emission options on the market that have been proven to be operationally feasible and are used in fleets currently. Statewide, we've estimated that GSE fleets are approximately 22% zero emission as of 2022. Currently, there are no regulations that directly address emissions from airport GSE. However, some GSE are subject to CARB's LSI and ORD regulations that have set fleet average emission targets that cover gasoline and diesel GSE. Additionally, the South Coast Air Quality Management District developed an MOU with 5 major airports in the South Coast Air Basin in order to reduce NOx emissions from GSE. Los Angeles International Airport, or LAX, has worked with their airline tenants and developed an agreement that all GSE at LAX shall be zero emission by 2033, unless exempt or no zero emission option is commercially available or operationally feasible. This could include, but is not limited to, fuel trucks, lavatory trucks, bobtails, air conditioners, GPUs, and all other GSE equipment categories that will be discussed in the second half of this presentation. LAX's program also has a few milestones along the way, including that by 2028, all GSE added to LAX shall be zero emission. And by 2030, all carts, baggage tractors, tugs, belt loaders, and aircraft tractors and tugs shall be zero emission. We would like to solicit any feedback on the GSE portion of this regulatory work. Included here are some starting points and suggestions for feedback that would be helpful, but all feedback is welcome. Specifically, we would like to ask if there are any GSE operators, what are some of your biggest hurdles with using electric GSE? For GSE manufacturers, are there any pieces of equipment that will be harder to offer zero emission options? And if so, why? Airport infrastructure for charging GSE, what planning needs to be done for this infrastructure? And is this for both airports as well as GSE operators? Finally, any suggestions on implementation timeframes and approaches for achieving a zero emission fleet would be greatly appreciated. And I will now pass it to Cindy Yanez to discuss aircraft operations at the gate.
Thank you, Jack. Next slide. The second portion of our rulemaking focuses on reducing emissions at the gate, specifically emissions from auxiliary power units, or APUs. An APU is a small gas turbine engine that's powered by jet fuel and is installed on board near the back of the aircraft, as shown on the image on the slide. When aircraft are parked at the gate and the main engines are shut off, the APU is used to power the aircraft electrical systems, such as navigation systems and onboard electronics. It also provides compressed air for the air conditioning systems to maintain comfortable conditions during boarding and pre-flight procedures. The APU also provides pneumatic power to start the main engines once the aircraft is ready to get going for its next flight. Next slide. This regulatory concept would require aircraft operators to plug into electrified gates instead of running the APU. Many airports already provide access to ground power and preconditioned air at their gates, and providing a practical alternative to running the APU. This diagram is showing an aircraft parked at an airport gate. The APU on the right is usually used to provide power for the onboard electrical systems and bleed air for the air conditioning while producing emissions. However, instead of running the APU, this concept would require the aircraft support crew to plug in the aircraft to the gate power shortly after arrival. Also, they would connect the preconditioned air supply to provide heating or cooling services to the aircraft. The APU would be shut off for as long as possible during boarding and pre- or post-flight procedures until the aircraft is about to depart and needs to start the main engines. Next slide. Based on current data, we estimate that the APU is typically run for 42 minutes per turnaround operation. That is 21 minutes per arrival and 21 minutes per departure. This is assuming that turnarounds take on average 72 minutes. Studies suggest that even when the airport gates are electrified, a portion of operations do not use ground power. A study conducted at San Francisco Airport found that 36% of operations do not use ground power at all. And for the ones that do use ground power, they found that they used it for an average of about 63% of their turnaround time. This regulatory framework would try to maximize use of the ground power wherever possible. Some airports, such as San Francisco and Fresno Airport, have already set APU usage restrictions at gates and imposed fees on tenants for violations. Some European airports also have APU restrictions, such as Schiphol Airport, where APU usage is restricted to 5 minutes after arrival and 5 minutes before departure. Next slide. As we are in the early stage of developing these regulatory concepts, we would welcome any feedback you have. For some starting points, we're interested in learning more about what is the maximum time frame that ground power and preconditioned air can be used instead of the APU. We've been in discussions with several airports, and we've heard that most airports are fully equipped or nearly fully equipped with electrified gates and provide ground power and preconditioned air to their tenants. We would like to know if there's any airports where that's not the case and about plans or pathways toward gate electrification. We'd also like your input on cases when there should be exceptions to APU usage restrictions and about timeframes for implementation. And lastly, please let us know if there's any other potential strategies for reducing emissions from gate operations. I will now pass it over to Dr. Lucas Algram to discuss the next regulatory concept.
Thanks, Cindy. The third part of our rulemaking will focus on taxiing emissions. During aircraft taxiing operations, pollutants are primarily emitted from the aircraft's engines, so the goal here is to minimize aircraft engine use while taxiing, either by using zero-emission technologies such as TaxiBot or wheel tug, or other low-emission strategies such as single-engine taxiing. While it's not uncommon to use other tug technologies to taxi aircraft without passengers, for example, to and from hangars for storage or maintenance, these technologies and strategies here can be further used to taxi aircraft with passengers to and from runways. Next slide. Technologies that are commercially available for zero-emission taxiing can generally be split into two categories: external tugs and onboard electric systems. An external tug, for example, TaxiBot, connects to the front wheel of the aircraft and pulls the plane forward. TaxiBot has diesel hybrid designs that are already in use at airports in other countries, but they also have battery electric models now available for order, as well as hydrogen-powered models under development. A key distinction about TaxiBot relative to other long-distance tugs is that they can be driven by the aircraft pilot from the cockpit, enabling it to be used to taxi loaded aircraft to and from runways. Onboard electric systems, for example, wheel tug or e-taxi, are onboard technologies that use electric motors to power the wheels of the aircraft. However, the electricity used is provided by the onboard APU. Next slide. So, what would taxiing using zero-emission tugs, such as TaxiBot, look like for a passenger-filled aircraft? When an aircraft lands, once off the runway and in a safe location, it can power down its engines, and the zero-emission tug connects to the front landing gear. The zero-emission tug then taxis the aircraft to the gate at the terminal. For departing flights, a zero-emission tug has the advantage that it can replace a conventional pushback tug. It connects to the aircraft at the gate, pushes it back from the gate, and then can immediately taxi out with air traffic control approval. Near the runway, the tug disconnects from the aircraft as its engines warm up in a safe location and prepares to take off. Next slide. Today in California, non-taxi bot tugs are being used to move empty aircraft without powering up the aircraft engines between hangars and terminals. But these movements can include using taxiways and even crossing runways. Taxi bot technologies have been deployed in several international locations. Trials have been carried out with diesel hybrid taxi bots at airports in Europe, such as the Frankfurt Airport in Germany, the Schiphol Airport in Amsterdam, and are more permanently implemented at Delhi and Bengaluru airports in India, where over 5,000 successful aircraft movements have been performed. Taxi bot demonstrations have shown that even though using the technology can be logistically challenging, there are promising implementation scenarios. The largest emissions and cost benefits come from longer distance taxiing scenarios, and spacious taxiways and service roads can further allow for an easier initial implementation. Next slide. CARB is planning to release a request for proposal, or RFP, in 2025 to conduct a feasibility study on this topic. The core focus of the study will be to analyze the feasibility of zero-emission taxiing at 3 to 5 select California airports, determine operational changes required to implement zero-emission taxiing at those California airports, and determine limitations in infrastructure, operational restrictions, or safety concerns that could prevent 100% adoption of zero-emission taxiing. And finally, also determine the cost of implementation. Next slide. CARB staff welcomes airports and airline input and participation in near-term zero-emission taxiing demonstration projects, or RFP evaluation. And additionally, we'd like to welcome feedback from communities and other stakeholders on zero-emission taxiing implementation or other approaches to reduce taxiing emissions. I will now pass it back to Dr. Sydney Yanez to discuss lowering emissions from takeoff and landings.
Thanks, Lucas. In the last concept, we're considering any and all other options for reducing aircraft emissions using existing technology and flight techniques. CARB is not looking to set aircraft engine certification standards, so we're therefore looking at opportunities for emission reductions within operational practices. For instance, one idea is to try to attract aircraft that already has cleaner technology to serve airports in the state. Secondly, another idea would be to modify takeoff, landing, or flight path in order to reduce emissions. Or a third option is to require airline spending accounts that would create funds to invest in lower emission technologies. I'll discuss each of these a little bit more in the next few slides. Next slide. For the first idea, aircraft operators would use takeoff and landing techniques that are known to reduce NOx emissions near the ground. Starting with landings, we have listed continuous descent approaches, which is a landing technique where the aircraft gradually descends down to the runway in a smooth, continuous fashion, instead of in step stair segments that are facilitated by air traffic control. So instead of going down like a staircase, the aircraft descends like a ramp. This reduces both NOx and fuel consumption because the aircraft is able to descend using low thrust, near idle settings and minimize bursts of acceleration and deceleration. To our knowledge, continuous descent approaches are already used regularly. So we think this technique is mostly resolved, which is great, since this approach is a win-win for several factors, including emissions, noise, and fuel use. But we would like to learn more about situations when it's not used and if there's room to optimize it to further achieve emission reductions. Secondly, we listed on here using optimized approach angles during descent, which could also reduce NOx by reducing fuel use and completing the descent more quickly. And then on the right side for takeoff strategies, using derated takeoffs could also significantly reduce NOx emissions. This would entail not applying full thrust during takeoff and instead using lower power settings. Some studies have shown that this reduces NOx emissions by 10 to 48% relative to using 100% thrust. And then lastly, another technique we've identified is optimizing the takeoff angle. Having a steeper takeoff allows the aircraft to climb to higher altitudes faster and thereby reducing NOx emissions near the ground. This is a practice that's already done at John Wayne Airport as a noise mitigation mechanism. Next slide. Moving forward to the second idea of this concept, which we call cleaner visits. As we mentioned earlier, some aircraft have already incorporated lower emission technology. We conducted some analysis using the ICAO emissions data bank, which includes reported emission certification data for aircraft engines. We match the engines to the aircraft they are used in based on activity data in our aviation inventory. Then we took a weighted average of the NOx certification values of the engines used in each aircraft to determine which aircraft have the lower NOx emitting engines. This bar chart shows the results for just narrow body aircraft. The aircraft are ordered from lower to higher NOx emitting, and the red dotted line shows the average value. You can see that there are some aircraft emitting as low as 52% lower than the average, while others are emitting 39% higher than the average. Next slide. As an example, I'm zooming in here to the Airbus A319neo aircraft, which we calculated to have the cleanest engines. The Airbus A319neo uses two engines, the LEAP 1A from CFM International and Pratt & Whitney's Pure Power PW1100G JM series. As we mentioned earlier, the LEAP engine has a TAPS 2 lean burn combustor that was developed with the FAA's CLEAN program. This specific version of the LEAP engine achieves NOx levels that are 52% lower than the CAPE 8 standard. The Pratt & Whitney engine uses a different combustor called the Talon X, which uses advanced rich quench lean combustion technology, and it achieves emission reductions of 35% lower than the standard. Next slide. And that was just one example for narrow body aircraft, but we also looked into what were the cleanest engines within regional jets and wide body aircraft. This is specifically for aircraft engine combinations that are already operating in California. This table shows the results by airframe category. For regional jets, we calculated that the Bombardier CRJ 700 has engine NOx certification levels 20% lower than the average regional jet. The Airbus A319neo has the cleanest engines within narrow-body aircraft, as discussed in the last slide. And for wide-body aircraft, we found that the Boeing 787-8 Dreamliner uses the cleanest engines in that category, which are 34% cleaner than the average. This analysis shows that moving towards lower NOx emitting aircraft by encouraging clean aircraft visits can be achieved now with existing commercial technologies. Significant emission benefits could be seen simply by encouraging visits from existing aircraft with cleaner engines that are already commercially available and in service. If we couple this idea with having those clean aircraft use SAF, then benefits for both NOx and PM could be achieved. Next slide. The final idea for this regulatory concept would be to establish emissions reduction spending accounts for airlines. The program would require airlines to create an account and deposit funds into that account that they would use to invest in zero emission or lower emission aircraft. The amount that they would each deposit into their account would be determined based on various factors such as their level of activity or total emissions in California. Then the funds they accumulate would be used to purchase cleaner technology to incorporate into their fleet. We welcome any feedback you have on this concept, such as what would be a good structure and time frame for a spending account program. Also, which factors could be considered for determining the contributions to the spending account. For example, it could be based not only on total emissions or activity, but higher contributions could be required if the activity patterns create heavier emission impacts on disadvantaged communities. Next slide. That concludes the fourth regulatory concept ideas. As with the other sections, we would love to hear your input and have listed some specific questions or interests here. Specifically, we'd like to learn more about how frequently some of these operational strategies we mentioned are already used. For instance, our current understanding is that the continuous descent approaches are done regularly, but we'd like feedback about situations when it is not used. Ideally, any data would be helpful about the number of operations that use continuous descent approaches or other innovative approach techniques. And if there are other operational strategies to reduce aircraft emissions during takeoffs and landings that we did not mention, we would also like to hear about those. Also, we'd like to learn more about how specific aircraft are routed to different airports, and what would be the logistics and feasibility of rerouting aircraft so that those with existing cleaner technologies can service priority areas in California. Perhaps it would be an economic measure, such as differentiated landing fees, such as what is done in some airports internationally, where there would be higher landing fees for aircraft with higher emissions. A measure like this would likely involve interstate cooperation between airports, and that would need cleaner visits more than others. And lastly, we'd like your input on what would be a feasible time frame and structure for a spending account program, and which factors we should consider when determining contributions. Now I'll pass it back to Mo, who will facilitate the Q&A session.
Thanks, Cindy. Thanks, everyone, for the first part of the presentation. Now we will have our first Q&A session. Please feel free to raise your hand if you would like to ask a question verbally, or alternatively, you can type your question in the Q&A box. We just realized that we have some technical difficulty seeing your question in the chat box, not the Q&A box. So I would encourage everyone, if you have a question or comment, submit them through the Q&A box instead of the chat box, so that we can keep in track of them. We were able to get some screenshots of the questions from our colleagues in the attendee. If you already put a question and comment in the chat box. So I saw some questions about posting the slides. And there's the same question through the Q&A box, which is already being addressed by David. For the slides, unfortunately, we were not be able to post them online before the workshop due to a part of the CARB server being down right now. But we will try our best to post them as soon as the service come back online after the workshop. So apologize. I saw a few comments in the webinar chat box. Thanks everyone for your comments, and we will definitely note down them and keep them in our record. Okay, I see two raised hand right now. I will, Kathleen, I will now unmute you and you can ask your question.
Great, thank you so much. Kathleen Van Osten, I represent United Airlines here in California. First, I do want to say that we do appreciate the recent MOU agreement that was signed by CARB and other agencies, as well as Airlines for America. It is frankly, it's a fabulous start in terms of increasing the production of SAF in California, and frankly, drawing SAF to California. Much of what's being produced is being sent out of state to other states that have higher credits in their LCFS. We had worked on legislation prior to this that was vetoed by the governor, so we're a little behind the curve here. But SAF truly is, as we have said many times before, the greatest opportunity to reduce emissions, including particulate matter, by at least 50%. In reviewing your presentation, there's definitely some interesting concepts. As you know, any technology that is used must be certified by the FAA, and oftentimes that takes quite a bit of time. So, you know, we're somewhat concerned about making sure that technology is available. I guess my question is, the federal regulations indicate that the FAA regulates all operations nose to tail by aircraft, whether it's gas consumption, whether it is operations, whether you're idling, not idling, taking off, not taking off. So I see that as a real sticking point for the airlines in terms of just going down that path. I think if there were strong voluntary discussions in terms of what can be used, the accessibility of that, the cost of that, various technologies would be useful conversations. This isn't about the airlines not wanting to reduce emissions. We have been pushing on the SAF issue for well over 10 years now, and you know, have really dedicated much of our efforts and continue to as we look at not just SAF infrastructure, you know, permitting for facilities, including biomass facilities to process, whether it's ag waste or woody biomass or solid municipal waste. There are a number of ways to get to SAF. But as far as the other technologies, I would offer and certainly recommend that CARB staff work closely with the airlines and the airports to seek voluntary methods of using those practices that you have mentioned. I can say that following the gas crisis back in the early 2000s, many of our techniques were modified internally for takeoffs, landings, the wingtips that you see that sort of became commonplace during that time, as well as any of our taxiing, takeoff and landing protocols. So I think there's some good conversations that the industry and CARB staff can have to get to a place where we can work together to really reduce these emissions as much as possible.
Thank you, Kathleen. It's a long question plus comment, so let me know if I miss any part, and my colleagues feel free to add to. I can give it staff first. Thank you. I think in terms of technology availability, some of the concepts we covered in our previous slides, for example, the plugging at the gate or the zero-emission GSE are already available today. Some technologies are not quite used in the United States, but they are used in other parts of the world. So we know they work, at least from a technology perspective. We're actively working with FAA and as well as soliciting conversations between airports and manufacturers, between them and FAA, to either assess the feasibility of any type of new technology, or just encourage FAA to consider approving those new technologies. So we're working on that. I believe a part of your question is also working actively with airlines and airports in terms of voluntarily deploying those new technology to reduce emissions. Yes, that's definitely something we would like to do, and we look forward to working more with airlines and airports in the future to reduce emissions. One of our slides shows that it's going to be a partnership. CARB cannot do this alone. Alrighty, I will move it to next raise hand on my screen. Aaron Coop, feel free to unmute and ask your question.
Great, thank you so much. Erin Cook from San Francisco International Airport. I want to thank the California Air Resources Board for looking into opportunities to improve air quality and improve human health throughout the state and certainly adjacent to airports. It is a huge priority for SFO. It's why we've implemented a lot of the measures that you've mentioned and also have been heavily focused on sustainable aviation fuel. As my colleague Kathy was just mentioning, I did maybe want to raise that up to, I don't know that you addressed if SAF will be part of this portfolio or how you envision the MOU with Airlines for America being a component of that. I guess my first question would just be, will that be part of the working group? And do you anticipate looking further into the benefits of the use of SAF? Because there certainly are reductions in sulfur oxides and particulate matter. Agreed, not so much on the NOx side, but even the Bay Area Air Quality Management District studied that about 4 years ago. So I think if we have the opportunity to make more investments, even if it is across the life cycle or certainly at the point of combustion, further studies would warrant a deeper investment by CARB and certainly other players within the state. And then maybe the second question that I would just raise up or maybe ask of careful consideration is that as CARB is going through this evaluation, just a better understanding of the types and techniques of analyses you'll be using to evaluate the cost effectiveness of the investments that you're proposing. So there's a huge portfolio of initiatives that you've walked through today. And again, appreciate that you're really looking to cast a wide net at this point to narrow it down to find the best solution. But I think we're really looking for the highest and best use of air quality improvements, and some of the measures you've mentioned may be incredibly costly and preventative in terms of cost from an airline and an airport perspective. So just really understanding what the cost effectiveness indices you'll use, ideally over the total cost of ownership of these assets that you're recommending or requesting to be procured. And I would just strongly encourage you also consider a component of that being the administrative burden. So if these technologies are implemented, it's not just about putting them in and actually managing the emission reductions over time. It's how we're quantifying them. What is the data source? How is that data shared? And then ultimately, who is the data owner? I think we long struggle at airports to be able to data gather from our airlines and even federal and state agencies. So just making sure we have kind of an open pro forma of how we'll engage in tracking, quantifying, and really sharing broadly the emission reductions that we're able to achieve as part of this effort, because we're obligated to do that for air quality for ourselves through regulatory requirements in Title V, but also through voluntary measures through the Airport Carbon Accreditation Program. So just wanting to make sure that there's a understanding of what the criteria is that you're using. And then, sorry, I would say very last question. So first is SAF, second is what indices you'll use, and then the third is just about getting more details on the timeline for implementation. I know we ran into this with the shuttle bus regulation previously, but airports are heavily reliant upon FAA grants that are available to us to make emission reduction improvements on our campuses, excuse me. And if this becomes an obligation, we are no longer eligible for things like VALE, the Voluntary Low Emission Reduction Program. So as soon as FAA knows that this is a mandate, it will basically inobligate us or make us ineligible from getting those grants. So having a more thorough timeline would be very helpful for us. So when we can expect that timeline would be my last question. Thank you.
Hi, Erin. Thanks for your questions. The first question about SAF, this effort is more focused on the operational practices and how that can help reduce emissions from aircraft. So SAF won't be a particular component in this conversation, but in general, CARB is in a position to encourage the production and use of SAF. I believe that question is more of a LCFS question. So it won't be this effort, but CARB is happy to see increasing production and use of SAF in aviation in general. Second question, we will do a thorough cost analysis as part of the rulemaking process. This is only the first workshop, so we're not there yet. But we would definitely need airports, airlines, all the stakeholders' help in providing as updated or as detailed cost numbers as possible to help us complete an accurate and comprehensive cost analysis. So that's actually part of the key input we're seeking from you guys. So any data would be helpful. But it will be a part of the rulemaking process, a cost analysis. Third, okay, I'm trying to remember what's your third question. The voluntary versus mandate. Yes, we're aware of that issue. We also heard similar comments or questions from some other airports we have toured before. We are looking into this, and we will try to investigate how we can try to avoid and do not hurt airports' capacity of getting funding from the federal agencies. Okay, I also see a question in the chat box from Hijang Zhang. Sorry if I pronounced your name not correctly. The question is, why should it take so long by 2031 to phase out leaded fuel, except that the aviation industry is very conservative of changing fuel? Does unleaded fuel with the same octane number make combustion unstable? Cindy, do you want to take that question?
Sure. Yeah, to our knowledge, there is a couple fuels that have been approved, unleaded fuels that are 100 octane, and they've been demonstrated to be safe and used on a STC basis. As to why it should take so long, I'm not sure if I have a good answer for that, but yeah, as we know, there is a fuel that's available, but they're still working on some trying to get one that's more fleet approved without the requirement of an STC. Not sure if anyone wants to add to that response.
Okay, and then there's another question in the chat box related to SAF production numbers. So I think it's still your question, Cindy. Is the 200 million gallons of SAF by 2035 a total production number or a per year number?
Oh, I believe it's a per year number. Sorry, I didn't explicitly state it before.
Okay, thank you, Cindy. There are a few other raised hands right now. So Kevin Welsh, feel free to unmute and ask a question.
Thank you. I think I'm unmuted now. Yes, thank you very much. This is Kevin Welsh from Airlines for America. First, just want to thank you all for the presentation, very detailed and thorough, covering a wide range of topics. Some others have spoken on some of the issues, so I guess I can be shorter. I do want to, Airlines for America represents U.S. passenger and cargo airlines, you know, number one on climate and local air quality. We're absolutely focused on net zero for our carbon emissions and reducing local air quality emissions. You know, really helpful overview of the challenge. And then when it comes to kind of what you all presented, again, appreciate the thoroughness and the fact that these are just concepts that you're exploring at this stage. Just in reaction, there's a pretty, you put out a lot of information with a very sort of wide range of, from my perspective of sort of feasibility. Some of the ideas may be very feasible, some seem very, very far from feasibility. And so, you know, I guess the question that, and the comment, it's a question and comment that kind of echoes what Aaron Cook said around the degree to which there's further precision around the timeline and scope of what you're pursuing, because there's a lot here. And so there's a real question in my mind about, what the, how you are going to sort of take next steps in terms of prioritizing work in this space and what the data sources are going to be, et cetera. So additional sort of clarity on that would be extremely helpful. And then the last thing I would say is, and again, this was raised by others, but there are many of these activities when we're talking about aircraft operations that are really in the realm of the federal government, and those are incredibly important for safety of aircraft primarily, but also to aircraft movements and coordination. So even taxiing, right, is critically important from a safety perspective. And so just understanding better the intent to work and how you plan to work with the FAA on these topics would be really important, because certainly they will have significant equities here. And then very last, but I think it's also just worth knowing, and just as an example of one of the ideas, like the idea, for example, of attracting kind of cleaner aircraft. I mean, those are very difficult issues to address given the networks of aircraft and where they fly, but also a recognition that, that there are trade-offs in terms of if one airport might get cleaner aircraft, then are other airports actually, where are the aircraft going and what the balances are. And so there's just many factors that need to be taken into account with these issues. And so, it would be very helpful for us ultimately to have some additional clarity about where the focus is going to be, what that timeline is going to be, and how, maybe coming back to your slide on stakeholders, which was a great slide, how you're going to work across those stakeholders on the particular paths that you go down in this would be really helpful. Thank you.
Thank you, Kevin. I can take a stab on your questions. So in terms of timeline, we don't have a specific timeline right now, as this is only the first workshop. So we're only proposing some concept we have studied in the past few months. And actually, it's one of the questions for all the stakeholders, that if you have any inputs or feedback on what do you think is a reasonable timeline or implementation procedure, we will welcome all those inputs for our consideration, so that we can present in our following workshop for further discussion. So this includes both how we can further refine the implementation scope and timeline, etc. So I don't know if that necessarily addresses your question. If any of my colleagues have anything to add.
Yes, this is Michael Benjamin from CARB. I do want to just say that one of our key drivers is attainment of the 70 parts per billion ozone standard. And we need to do that by 2037 at the latest. If we don't attain the standard, then there are federal sanctions, including potential loss of federal highway funds. So as was mentioned in the presentation, we're going to need very significant reductions of NOx, not greenhouse gases, but NOx from aircraft in California by 2037. So it's going to require some very profound changes. I'm just saying that so that everybody understands that the conversation about the timeline is not open-ended. We are under extreme pressure to achieve very significant NOx reductions from aircraft in California.
Thank you, Michael. I think we only have time for one more question this round, and then we can save the rest of the question to the end of the workshop for the sake of time. Bill McGovern, I have allowed you to unmute yourself and ask your question.
Thank you. This is Bill McGavern with the Coalition for Clean Air. We were one of the sponsors of SB 1193 to ban lead from aviation fuel. So I want to first respond to the question about that, about why the timeline is so delayed. And the answer is, in the earlier language of the bill, we had a much earlier phase out, but there was opposition from some sectors of the industry. And it was the chair of the Assembly Transportation Committee who insisted that we change it instead to a full ban in 2031. So it's disappointing that it's that late, but on the other hand, it is helpful that we've got that on the books and hope that other states will follow. I want to thank CARB for holding this workshop today. The emission increases projected to come from this sector are really striking, especially in comparison to the decreases that we're looking at from other sectors. And many worker and community advocates were disappointed that more was not done in the low carbon fuel standard amendments recently to take on aviation emissions. So we think that the goal should be zero emission ground operations, and hope that this rulemaking process will move along expeditiously. My question is, will you be doing analyses of the health impacts of various measures, health impacts on workers, on passengers, and on community residents? Thank you.
Cindy, I think that belongs to your part of the presentation. Do you want to try and answer that?
Yeah, sure. I think we also thank you, Bill, for clarifying the question about the time frame. That was helpful for me as well. Yeah, I think we do plan on conducting analysis like that, and also working with community groups to get as well informed as we can on emission impacts in local areas. Yeah, I think down the line we will be looking to do analysis of public health impacts.
Thank you.
Cindy, this is Michael Benjamin from CARB again. I think what I'd like to add is that one of the stakeholder groups not shown on the partnership slide is universities and academic institutions. We would very much welcome any partnerships with any universities who would be interested in conducting exposure studies in California, as well as any airports and airlines who would be willing to collaborate in such a study. I think it would be very useful and relevant to be able to have additional California specific exposure studies conducted.
All right, thank you for all the questions so far. We will move on to the second part of the presentation, and then you guys have another opportunity to ask questions at the end of the workshop. So now I will hand it over to Dr. Rami Tauhidi for the emission inventory updates.
Thank you, Mo. Next slide, please. Okay, in previous slides, we discussed the various emission sources at airports, and CARB has developed and is continuing to develop models to capture emissions from all these sources. For on-road traffic to and from airports, emissions are captured by the INFACT model. This model accounts for emissions from on-road gasoline, diesel, propane, and natural gas engines, as well as brake and tire wear. The INFACT model is updated regularly to incorporate the latest data and regulations. The next update is planned for early 2025. And revisions will continue every 3 to 4 years. Next slide, please. Building on the previous slide, where we focus on on-road traffic emissions, let's now look at emissions from ground support equipment, or GSE. These emissions, which primarily come from gasoline, diesel, and propane and natural gas engines, are now being independently captured in a statewide inventory model under development. This approach separates GSE emissions from broader categories, providing a more detailed and accurate representation of their impact. By distinguishing GSE emissions, CARB aims to better understand and address the specific contributions of these vehicles to overall airport emissions. Next slide, please. Emissions from aircraft at gates and during taxiing, landing, and takeoffs are captured by the California Aircraft Inventory, or CAI model, developed by CARB. These emissions originate from two primary sources: jet engines and auxiliary power units, also known as APUs. The CAI model ensures that emissions from these specific sources are accounted for separately, offering a comprehensive understanding of their environmental impact during various stages of aircraft operation. In the next slides, my colleague Dr. Algrim will delve into more details about the CAI inventory. It's you, Doctor. Next slide, please.
Thanks, Ramin. The new statewide California Aircraft Inventory, or CAI 2024 for short, is an inventory model that captures statewide aircraft activities, which excludes GSE activity. And based off that aircraft activity, it estimates aircraft emissions. The model includes all major types of aircraft, such as commercial, general aviation, agricultural, rotorcraft, and military. The emission estimates are based on flight activity and fleet mix and is ultimately constrained by the LTO cycle, which is defined by a mixing height. The final version of this model should be released by the end of this calendar year, 2024. If you'd like to learn more details about this model than what we provide here, there is a link on this slide that'll take you to a recent workshop in October that was entirely devoted to this model. Next slide, please. So as mentioned, the LTO cycle is constrained by mixing heights, which are that's the height above the ground surface at which a pollutant can be readily dispersed by turbulent mixing of the atmosphere. Once an arriving aircraft has descended below the mixing height, it's officially began its LTO cycle. The aircraft touches down on the runway, slows to taxiing speeds, takes the taxiways to the airport gates. After unloading and reboarding passengers, the aircraft taxis back to the runway and takes off. And once the aircraft has climbed to an elevation above the mixing height, it has officially ended its LTO cycle. Next slide. Here we'll discuss some of the specific parameters used in the CAI 2024 model. The federal SIP conformity rules specify emissions up to 3,000 feet can be considered in the absence of region-specific analysis, but CARB staff determined airport-specific mixing heights based on AERO5 data. The airport-specific values can vary greatly, but they do generally fall on average around 3,000 feet. CARB staff determined that on average, taxi in times are about 6 minutes and taxi out times are a little over 15 minutes. But again, these can vary from airport to airport. It was estimated, as Cindy had mentioned previously, that 42 minutes of APU usage are needed for all flights at all airports in California. Next slide. Prior to this model, regional air districts prepared aircraft inventories, but moving forward, CARB will prepare the aircraft emissions inventories within CAI 2024 model to ensure statewide consistency. CARB will be evaluating and, if needed, updating the CAI 2024 model before finalizing the rule proposal in 2027. And with that, I'll hand it back to Dr. Ramin Tawhidi to discuss the statewide GSE inventory.
Thank you, Lucas. As we discussed, airport GSE includes motorized vehicles used on airside area like tarmac and taxiways to support aircraft operations. These range from tugs and tractors for towing to specialized trucks like fuel and catering vehicles. and loaders for cargo handling. GSE plays a vital role in ensuring efficient and safe operation, from fueling planes to managing luggages and cargo, keeping airports running smoothly. Next slide, please. Tugs and tractors make up about 40% of the total GSC at airports statewide. Aircraft tractors are essential for pushback and repositioning, while baggage tractors are used for routine baggage handling. Baggage tugs can be used interchangeably with baggage tractors, handle heavier duty tasks. Cargo tractors, on the other hand, are used to move cargo containers and pallets. Together, these vehicles play a key role in keeping airport operation running smoothly. Next slide, please. Specialized trucks make up 12% of the total statewide ground support equipment at airports and are designed for a specific ground handling task. Bobtail trucks are heavy-duty vehicles used for various operations, while catering trucks deliver food and beverages to aircraft. Fuel trucks and hydrant trucks supply fuel either directly or through hydrant systems. Water trucks manage waste servicing. Water trucks provide potable water, and service trucks handle general maintenance tasks on the airfield. Next slide, please. Of loaders and on-site equipment accounts for about 40% of the total statewide ground support equipment at airports. Loaders handle tasks like loading luggages, cargo, and personnel. For example, belt loaders are used to move luggages onto aircraft, while cargo loaders handle heavier items. Lifts and passenger stands provide access to aircraft for passengers and crew. On-site equipment like air conditioners, air start units, laboratories, carts, and generators have their own engines, but typically need to be towed between locations. Next slide, please. Okay, let's discuss the current regulations on GSC. As we discussed, these regulations fall mainly into two frameworks. First, the large spark ignitions or engines, or LSI fleet rule, which addresses equipment types using spark ignition engines, commonly fueled by gasoline or propane. The second key framework is the off-road in use off-road diesel rule, or ORD. This one targets diesel-powered GSC that generally has a higher emission profile. For LSI, the reporting requirements through the DOORS program ended in 2023. For ORD fleet rule, there's a structured reporting schedule based on the fleet size. Large and medium fleets have been required to report emissions data annually since 2016, with reporting ending in 2023. While small fleets started reporting later in 2018 and will continue until 2028. After these deadlines, any fleet failing to meet its final emissions targets must continue reporting annually until compliance is reached. However, with the reduction in direct reporting checks for both LSI and ORD fleets, there could be an impact on future tracking and compliance processes for GSC. Due to these checkpoints, it's become necessary to adjust the population database that is reported through DOORS system, focusing specifically on GSC at airports to address any gaps. Next slide, please. There are two primary limitations in current GSC reporting framework. First, there are no specific reporting requirements for GSC under either the ORD or LSI regulations, and these regulations do not apply to all equipments. For instance, electric equipment is only reported if it's necessary to meet a fleet's average emissions target, and businesses with 3 or fewer pieces of equipment or engines under 25 horsepower are exempt. Second, annual operating hours are not required to be reported. So the current GSC emission inventory relies on limited data points for activity data. As for emission factors, we are working on updating them for the release and may incorporate the new portable emissions monitoring system PEMS approach. Next slide, please. The South Coast MOUs provide highly reliable data on GSC populations at 5 major airports, giving us a solid foundation for understanding GSC distribution across other regions. For other airports, our GSC population estimates rely on data from the DOOR system, which, while only moderately reliable, still provides valuable insights for our statewide analysis. As illustrated in the Venn diagram, there are some GSC types reported in MOUs that do not appear in the DOOR system, highlighting differences in data coverage. To enhance our statewide GSC estimates, we applied the operational data to GSC ratio observed at South Coast airports, taking into account metrics like passenger traffic, freight volumes, and commercial aircraft operations. This approach allows us to better approximate GSC population at other airports using the reliable data from South Coast as a benchmark. Next slide, please. Okay, this slide presents the preliminary estimates of a statewide GSC population, combining data from both DOORs and MOU sources. The total count is approximately 11,300 pieces of equipment. Compared to CARB's current model, we see an increase from 9,600 in 2023 calendar year. While these are still preliminary estimates, we believe the actual count could be even higher. Going forward, we will continue updating this data set to include all vehicles types, ensuring a more accurate estimates of GSC as we gather additional data from other airports. Next slide. This chart shows the fuel type distribution as a percentage across different vehicle types, sorted by electric vehicle adaptation. Gasoline and diesel remains the dominant fuel type in most categories, specifically for high-demand vehicles like cargo tractors. To provide more context, the absolute counts for each category are also displayed. It's promising to see some level of electric GSC adaptation in high-demand equipment, indicating potential for further transition to electric option. However, challenges persist for equipment requiring higher engine power. CARB staff are actively evaluating the feasibility of zero-emission GSC penetration, while considering the limitations of certain categories. Next slide, please. CARB is conducting a voluntary GSC survey to enhance estimates of equipment, fuel use, and activity data. We are actively collaborating with airports and California Airports Council or CAC to finalize this survey. It will be distributed through airports and the CAC and will also be made available for download on our website by the end of December 2024. I should mention that accurate data is critical for developing reliable estimates. Without your inputs, we may need to rely on assumptions that could potentially overestimate emissions. By participating, we can help ensure that the data reflects actual conditions and leads to more precise and effective policy decisions. Our goal is to complete the survey by February 2025. And we greatly appreciate your timely participation to help us achieve this. Next slide, please. For the survey, we have outlined 2 scenarios based on your situation. If your equipment is registered indoors with an equipment identification number, EIN, all you need to do is enter data such as annual operating hours and fuel usage details, including the type and the volume. For equipment that isn't registered indoors, like electric vehicles or new additions to your fleet running on gasoline or diesel, please provide relevant vehicle data and activity metrics. While we prefer data from 2023, Submissions from other years are also welcome. And if you'd rather use your own format instead of the spreadsheet, that's perfectly fine. We are happy to accept any format that can be shared directly with our. As a part of our outreach, we've been working closely with environmental departments and some major airports, and all of them have agreed to collaborate with CARB to gather activity data and serve as a liaison between us and GSE owners. So if it's easier for you, you can share your information directly with the airports and they'll pass it on to us. Okay, that wraps up the inventory section. I'll handle it over to Dr. Chen now to cover our future plans and next step. Dr. Chen, over to you.
Thank you, Ramin. Again, one of the major purposes of today's workshop is to see feedback. We would appreciate if stakeholders can share any data sources that can help with improving emissions inventory, cost analysis, feasibility analysis, etc. We welcome feedback on the proposed concepts and alternatives to proposed concepts. More specifically, in order to inform cost, economic, and other rulemaking analysis, such as the Standardized Rule Regulatory Impact Assessment, SRIA, we request alternatives that yield the same or greater benefits than proposed regulatory concepts, or do not yield, or are less likely to yield the same level of benefits than the proposed regulatory concepts. Next slide, please. Here's the timeline for next steps. We had the first workshop today. We will open for 60 days after today's workshop to collect questions and comments. So the deadline will be February the 10th, 2025. In 2025, CARB plans to host an aviation tech forum in collaboration with US EPA and South Coast Air Quality Management District. CARB also plans to release an RFP for a zero-emission taxing feasibility study. We will also be preparing to have a second workshop in 2025, as well as working on developing a community engagement plan to make sure we keep community members in the loop throughout the rulemaking process. We expect to host additional workshops and continue stakeholder engagement in 2026. We plan to send this item to our board for a first hearing in 2027. If it gets passed, the implementation is planned to start in 2030, and we expect to see maximum emission reduction by 2033 and 2037, 10 years. Please note this is just a tentative timeline subject to change. Next slide, please. Here is my, as well as my supervisor's, my supervisor, Dr. David Curie's contact information. We also have two websites related to this aircraft topic, one on zero emission GSE and one on zero emission ground operations, and you can find the links on this slide. We highly encourage you to subscribe to either of the website subscription list. And there's a direct link right up, after each of the website on the screen, so you can always get the latest information from CARB. And again, the slide deck will be posted on our website after the workshop. Next slide, please. Now we will have our second Q&A session today. Please know that for the sake of time, try to be brief when you ask your question. We would really appreciate it. Okay, and then I will call on the ones that have their hands raised. Mariella Ruacho, feel free to unmute and ask your question. Mariella, if you're speaking, we cannot hear you just yet. Okay, we probably can come back to you, or you can type your question in the Q&A box. Sarah Small.
Hi, yes. Can you hear me now?
Yes.
Great, thanks. And I'll try to keep things concise. I threw some comments in the chat and really appreciate the invitation to provide public comment. We'll definitely go ahead and do that. I work with Communities for a Better Environment in East Oakland, and I'm also involved in our organization is co-chairing our AB 617 CERT process with BACMed. Our community, of course, borders the Oakland International Airport and has raised a lot of concerns in recent years about impacts there. So would really appreciate being able to engage in some more conversation with you all in the coming months. I think in addition to sort of more substantive questions, would just really like to encourage, actively seeking out community input prior to sort of any close of comments or next phases, like really reaching out to community where they are and with language accessible materials and really actively soliciting input, not just sort of keeping folks in the loop or updating. I know folks have challenges in making some of these times, but have a lot of, a lot of our membership has a lot of strong feelings and a lot of lived experience to contribute to this, as well as, workers that I'm sure you're familiar with through various unions. I think, raised a few different things in comments. I just wanted to suggest sort of some additional pathways and curious to hear if you all are considering sort of, in addition to sort of the big ticket regulations, which we're certainly interested in, addressing like the more immediate needs of community. I think considering sort of early actions that can be moved to improve conditions prior to regulations being in place, whether that's incentives or more community health resources, parallel MOU processes. We'd be very interested in hearing more about any plans for those and partnering to brainstorm on those, whether that's through the 617 process or externally. And also one of the things our community has run up against and is, underway right now is the CEQA process around the Oakland Airport expansion. And I know other communities near airports frequently, a lot of the LAX work happened around an expansion. So curious to hear if there's any plans to update how CARB is involved in expansion projects or modernization projects, and that may also include CEQA guidance updates that could be beneficial to protecting community health. And that is plenty of time to take up. I will pause there and hope to speak with you all more soon.
Thank you, Sarah. This is David Kiros, Branch Chief of the Aviation Programs here at CARB. Really appreciate your engagement and your comments, both verbal and those that you wrote down. Just a slide or two ago, we showed a timeline, and a priority for us in 2025 is to come up with a community engagement plan. So we definitely want to follow up with you and any other organizations throughout the state to better understand what the concerns are and ways that we can structure this regulation to maximize the health protections from what we do for your communities. Just quickly touching on a couple other things that you mentioned, both in writing and verbally. We are in contact with our colleagues in the Transportation and Toxics Division that oversee our CEQA program. They've been tracking a lot of the freight projects, and we've talked with them about also tracking airport-related projects to see what opportunities there are for us to expand the comment letters that we do send out. We can't commit to commenting on every project, but exploring opportunities to make comments and provide guidance is something that we can consider. On the Cal OSHA side, you talked about ways to quantify the impacts to workers and what can be done in the near term. Typically, when we do a regulation, always when we do a regulation, there's an impact regionally on the reduction in mortality and morbidity associated with the reduction in air pollution. Sometimes there's a health risk assessment for a specific toxic in the vicinity of a source that's being controlled, but we don't always do them, and it's typically just for residents. So we've also started the conversation about what about airport workers? Is that something that we could explore, or is CARB going to be going beyond our typical lane and going into the territory of Cal OSHA? And so there's always an opportunity, as Dr. Michael Benjamin talked about, to better quantify what the exposure is for workers and communities. And if we can work with you to better frame how we can do that in a meaningful and effective way, then we are on board with that. One final comment. We are working with our enforcement division on determining if there's any type of supplemental environmental project that can be put forward, whether it's for lead exposure or just for reducing exposure to jet exhaust from airports. Filtration seems promising. We might need to look into that more to see if that's the most effective way to go. But if we can work together to come up with a supplemental environmental project that would benefit your community or others, then that's something that we would be willing to explore with you. So I'll stop there and turn it back to Mo to go to the rest of the questions, and let us know, Sarah, if you have any further comments.
Thank you, David. Right, Jim Light. Jim, you should be able to unmute yourself.
Okay, thanks, Mo. A couple of things. I've got a number of comments, but I'm going to limit them really to two. I have to underscore Aaron Cook's comment number 3 about airport eligibility for federal FAA grants for environmental projects. We really cut ourselves off from those grants with the shuttle bus regulation. And I would hate to see us take another step that limits our ability to utilize those grant programs. California airports were the largest recipients of those grants prior to the shuttle bus reg being enacted. And it's very important for us to be able to access those funds and not be really limited to CARB funding programs where airports are competing with other sectors of the transportation economy for those funds. Second, in the airline account program that was suggested, I'm gonna speak on behalf and in support of our airline partners here. As I think we've shared with CARB, California is one of several states that remains out of compliance on the allocation of sales tax receipts paid for jet fuel. And the FAA has been working with the state for a number of years. We remain out of compliance. The airlines are the largest group of taxpayers in that discussion. And so rather than ask them to pay into a new fund, the state should in fact be getting into compliance with existing federal law and could certainly allocate some of those funds that are today going into the general fund to support some of the programs that you guys have outlined today. And so we obviously look forward to continuing to work with you guys on this and helping to gather airport data and information as you go forward. So thank you very much, Mo. We'll be in touch.
Thank you, Jim. Look forward to working more with you. Sorry, I was on mute. I just want to circle back to a previous question in the chat box earlier in the presentation from Crystal Delatari. Is there any discussion regarding assistance with funding infrastructure planning projects for airports? Jack, do you want to take that question?
Sure, yeah. Thanks, Crystal, for the question. I think, there's, as Jim was saying, some funding opportunities at the federal level that we've talked about. And I think we'll continue to work closely with, the federal government as well as state and local agencies to see if there's any potential expansion opportunities for those as they relate to infrastructure at airports. And for those that may or may not be familiar, there is also the California CORE program, which has specific incentive funding for primarily off-road equipment, but there are some GSE ground support related equipment on there as well. So if you're not familiar with that program, it could potentially be used by GSE operators to reduce some of the additional cost for obtaining zero emission equipment. And thank you for the comment. We'll definitely want to keep incentive funding sources in mind as we move forward.
Thank you, Jack. Beverly Des Charles. Sorry if I'm not saying your name correctly.
Deschaux, thank you. This is Beverly Deschaux with the Electric Vehicle Association of California Central Coast. Thank you for that presentation. So much information, and I'm so happy that you are working on these things. And I have a few comments. One, I want to encourage you that all ground operations be immediately transitioned to electric. That you have 87% that isn't being addressed because it's from the jet fuel means that at least you could get quickly going to transitioning to all electric, your ground support, you're at the gate. CARB is also already handling the to and from airport traffic with vehicle regulations. I want to caution you against considering fuel cell because for several reasons. One is that the infrastructure, the charging, the fueling, is extremely costly and you don't already have it that I know of, whereas you do already have access to electricity. The other thing is that currently 95 to 98% of hydrogen is produced by fossil fuels. So while you may not be having tailpipe emissions locally, you're not making real reductions in emissions because those emissions are still being produced to produce hydrogen. And yes, you can make green hydrogen, but it's not being made to scale, and it will cost an enormous amount of money to get all the renewables to make renewable hydrogen. The other thing that I want to say is, the Center for Biological Diversity has done some research on biomass and biofuels and woody mass. And there are actually no reduction in emissions from using that source of fuel, those sources of fuel. So I encourage you to look into that, maybe even check in with them to find out their research on that so that we don't waste time going down that path. So this is a good start. It's a great start, what you're doing. And what's going to happen with the jet fuel? How are we going to get jet fuel down to zero emissions? Do we hope to get it down to zero emissions? And, what is the pathway for actually producing jet fuel that's sustainable? And what is your definition for sustainable fuel? Thank you.
Thank you, Beverly, for your comments and input. Is your last sentence a question or is it part of your comment? Just want to make sure.
I'm sorry, what?
I just want to make sure I understand correctly. Is your last part of your comment, you phrase it as a question or is it just part of your comment?
No, they're actual questions. What is your definition of sustainable fuel, and what is your pathway to actually achieving that 87% emissions coming from the airports that is actually coming from the jet fuel?
Got it.
I think zero. Yeah.
Right. I can try to take a stab here. The sustainable aviation fuel, I think, is when it has a very specific definition that they're coming from maybe a wide variety of stock. that are considered more renewable or did not directly come from refinement of fossil fuels. So that will reduce their life cycle carbon emissions. However, as we point out in one of those slides, the scoping plan does have a goal of having at least 20% of the aircraft powered by either electricity or hydrogen by 2045, and then supplement the rest of the 80% by sustainable aviation fuel. That is, I think, primarily because we recognize that technically, it may not be as feasible to power all aircraft, commercial aircraft, with electricity or hydrogen by 2045. So we have to complement that, the rest of it, with sustainable aviation fuel. But I think that's CARB's current goal. Hopefully that helped clarify some of the question there. All right, we are right at 3 o'clock. I see okay, I don't see any raised hand anymore. There is one more comment in the Q&A box from Catherine. Thank you for your comment. Yeah. Alrighty. I think that concludes our workshop today. Again, I want to thank everyone who participated and give your input and feedback during the workshop. I want to remind everyone, after the workshop, you have 60 days to submit any questions or comments or input feedback to the email box on the screen right now. We're happy to accept all your comments and feedback and look forward to working with you more on this topic. Thank you, everyone. Bye.